At least from my perspective and my experience, it is that you keep getting challenges but you need to persevere it through. We are coming in with our own newer, better automated manufacturing process to, in a way, revolutionizing this world. Persevere and be flexible about it, not just be stubborn. You cannot keep doing the same thing and expect some things will change. We felt that we could crack it. We knew that we had the ability in terms of technology, capability, engineering-wise, we knew that we would be able to crack it. The material part we have cracked, and the critical part of the mission also we have cracked. With that, we were able to go to investors and showcase and able to get the funding.
Hi, this is Amrit. We are at IIT Madras, my alma mater, and India's top university for people who like to build. We are here to meet some builders, ask them, what are you building? What does it take to build? And what makes IIT Madras the best place to build? Hello and welcome to the Best Place to Build podcast. Today we are sitting with Dhinesh from a company called Fabheads, started in 2016, but recently in the news in 2025 because they've raised a lot of funding. They are in a space called additive manufacturing, which I'm personally very curious to because my subject in college was mechanical engineering. Hi Dhinesh, welcome to the podcast. Dhinesh, can you tell us what Fabheads does?
So at Fabheads, we primarily focus on a group of materials called composite materials. So these are materials like carbon fiber, Kevlar, glass, and so on. So this is a group of materials that has been only around since 20th century. But in spite of being around for a very short time, they have very amazing properties. They just feel like plastics, but they're as strong as stainless steel. And they're also incredibly safe. Corrosion resistance and so on. So because of several of these magic qualities coming into one single material, they are becoming the go-to material across, say, shipping, aerospace, defense, and a lot of sectors. Even over titanium, you might have heard of biomedical implants, right? The hip replacement and so on. Traditionally, people have been using titanium by and large, but now people are slowly moving towards carbon fiber-based systems. So like this, they're slowly replacing a lot of materials. But if you look at how these components are fabricated, they are done by manual manufacturing process. So that is where we are coming in with our own newer, better automated manufacturing process to, in a way, revolutionizing this world. Yeah.
So you manufacture advanced material? No, components made of advanced materials,
Yeah,
right?
correct.
Okay. In additive way, what does that mean?
Yeah. So if you, by and large, look at, say, plastics or metals, there are a lot of manufacturing processes out there. Like you can make it by injection molding for plastics or 3D printing for plastic, and similarly casting, sheet metal bending, and even again 3D printing for metals and so on.
I remember my first class ever at IIT was lathe.
Yeah.
Which is turning.
Yes.
Which is also a manufacturing process.
Correct. A lot of these reductive manufacturing processes like machining, milling, lathe, EDM, and so on. So a lot of machining, like where reductive processes are there. So these are by and large how metals and plastics are fabricated. In composites, if you look at the unique property of what composite offers, directionality. We might call all these materials like plastics, metals as by and large they are all isotropic materials. But fiber composites are actually something, it comes in a group of materials called anisotropic materials. So what that means is they don't behave the same way across all directions. So like fiber is kind of like thread, right? So you take a thread, along the direction of the thread, it is going to have a very high strength, but I can easily cut off thread. In the perpendicular direction, you cannot take much load essentially. So that is how when I'm making anything with these fiber-based composite materials, how I am directionally laying these fibers will be very critical. Because of these reasons, casting or machining kind of processes don't really work for composite materials. That is why people traditionally, they take sheets of like almost like textile cloth. They take sheets of fabric of glass fiber or carbon fiber and so on, and then they lay it layer by layer, and then they cure it in an oven. That kind of solidifies.
Sure. So just to replay some of the things you said, traditionally metals and plastics have been made with reductive removing material through various processes or via casting or molding.
Yeah.
Where you need a mold and you pour the liquid material and then you remove the mold.
Forms it. Yeah.
Right. And the process that you are saying is that these materials metals and plastics are isotropic, which means this way or that way it provides the same qualities.
Yeah.
But that's not true in carbon fiber.
Correct.
And then you said that in carbon fiber, the traditional process is you take a sheet, put a layer of resin, take another sheet, put a layer of resin, and so on. Right?
Yeah. Correct.
Okay. But this is not what you're doing.
So no, we don't do this. So we typically, this is something that a man has to do. Labor intensive. It's a very labor intensive process. And when they apply these resins also, they have to be very careful that the resin is spread across the full fabric in a very uniform manner.
When we say that an aircraft body, like a Boeing aircraft body, is made of carbon fiber, then you're saying a person has actually laid the resin and the entire wing has been manually done?
Yes.
Really?
So not just aircrafts. Can you imagine the wind turbine blade, which are like even larger than aircraft, 60 meters, 70 meters, and so on. All these, every single wind turbine blade is either made of glass fiber or carbon fiber or hand laid. So you can imagine, like you can see some YouTube videos where about 50, 60 people will be sitting on top of one big mold of a glass for a wind turbine blade, and they will be laying down sheets of glass fiber or carbon fiber. So it's a very manually intensively processed, really. And that is how today ISRO's rockets are being made. The fighter jets of LCA Tejas, for example, they are all handcrafted. The full body of LCA Tejas today, which is our own fighter jet, the full body, it's almost 70% by weight is by carbon fiber, and they're all hand laid. And we don't have enough trained technicians in India anymore to scale up the production capacity.
And you said Kevlar also. So all those like Kevlar body vests, which are supposed to be bulletproof, they're handmade.
So they are kind of like most textile engineering. Okay. But you are looking at more high performance, like a Kevlar for say tanks and so on. So those are hand laid sort of.
Okay.
So the ones that you see in the body armor,
Kevlar thread.
Kevlar threads, kind of like woven, like kind of like textile work sort of. But yeah.
Okay. So
essentially what we are working on. So because now you get an idea of how manually intensive this whole process is, and we have developed our own automated manufacturing process to make this process automated. So along with us, there are only about 7 companies across the world who do this, and because of the extent of its capabilities, it's also a technology that India cannot actually import in India, though there are a few countries across the world that have this. So we are the only ones doing it in India for the first time.
Composite 3D printing, composite additive manufacturing. There are only 7 countries in the world which can do it.
7 companies across the world.
Oh, wow. Okay.
Yeah.
And this is useful because these are all these advanced processes, advanced components that require this.
Yeah. So you take a look at anywhere you are looking at lightweighting and high performance, anything that literally that flies. Every drone today is made out of carbon fiber, not just a defense grade. You are looking at a high performance photography drones, they are made with carbon fiber. And locomotives today. Today in India, all the locomotives are still metal. But if you look at China, France and others, they are slowly moving from metals to glass fiber or carbon fiber based locomotives because they are lighter and they can travel much more fuel efficient and so on.
Right.
So, yeah. So ships, automotive, transport, mobility, everywhere.
Okay, I heard you. But what are you doing in this?
So yeah, we have developed our own manufacturing processes, as I said. Currently, we are more focused on drones because our missions are fairly small at the moment. We can make components of up to 1.5 meter today with the missions that we have in our facility. We are doing primarily some components for drones, ISRO rockets we are building, then some automotive robotics. These are the kind of work that we are.
These are machines that you have built?
Yeah.
Okay, so you have built machines that do additive composite manufacturing.
Yeah.
Additive manufacturing with composite materials.
Yeah, correct.
And then you make the parts also.
Yes. So currently we don't sell the machines at the moment. We do sell to IITs and academia as kind of as a technology evangelization sort of. But by and large, we don't sell the machines per se, but we operate on a manufacturing as a service model, MaaS we call it. So where we build our own factories and we take orders from our clients and is fabricated and supplied to them.
Understood. I did read the news article about a year or two back where you gave about 100 machines to IIT Madras. Is that correct?
Not 100, 30 machines.
30 machines to IIT Madras. So students here actually have access to your composite 3D printing.
So the machines that we build, we also have understanding with our dean that we have to compulsorily upgrade it to our latest generation missions within 5 years.
Nice.
So we will ensure that not only the same missions continue to be there, but we'll keep upgrading also.
I have had this really unique experience. This is, we are sitting at the Center for Innovation and they have a 3D printing club.
Yeah.
So I was walking around one day, many years back, maybe 2-3 years back, and I saw the 3D printing club. And I think that day it was a holiday, nobody was there, but some students were there in the 3D printing club. So I went and asked them, what are you printing? And they kind of laughed at me and said, we are not printing anything, we are building the machine. I was like, okay, fine.
So yeah, very true. Like even ourselves, right? We are building a mission. So pretty much for 3 years, we were just trying out a lot of prototypes of the missions. So we didn't want to make it metal because we know things will go wrong. Things will kind of, we'll still iterate it. All the components, nearly 95% of the components that went for about 3 years in the first R&D period, were all 3D printed by ourselves. So we also 3D printed the missions that were actually we were building also.
Nice. That's really interesting. I want to ask you a question about that. When did 3D printing become additive manufacturing? It feels like there was a period when everybody called it 3D printing.
Yeah.
And then the whole industry decided we will never use this term again. And it became additive manufacturing.
Yeah.
Right?
So coming from a composites industry, right? I have a completely different view on it, which many plastics and metal guys will disagree with. But that's what I'm going to offer. All right. If you look at additive manufacturing, composites, ever since it was developed in 1920s, glass fiber was developed, we have been fabricating with additive manufacturing.
Right? Oh, right. Because it's
layer by layer. We are taking a fabric of sheet, you're manually laying down fiber, and then you're adding resin to it, and then another layer of fiber. Depending on how much thickness you want, that many layers of fiber you add. So composites have traditionally been always done by additive manufacturing. So additive manufacturing is kind of just like you just add material, right?
Yeah.
So there is a process called winding. You might have heard about coil winding or in electronics, or there's a similar process called winding in composites also, where you take any pressure vessels, for example, any cylindrical pressure vessels like
a submarine,
scuba tanks, not submarines, but scuba tanks or
Hyperloop.
Yes, Hyperloop. Any the CNG tanks in cars and so on. Yeah. All these tanks are made by a process called filament winding, which is essentially like you imagine a lathe machine, right? It moves exactly. There is a spindle that rotates, and then there is a tool head that moves left and right. But instead of the tool head removing material, it has a thread that goes through the spindle, and as the mandrel rotates, the material keeps getting rolled. So you are getting it. So it is kind of like exactly a combination of lathe converted into an additive manufacturing. So instead of the tool removing material, it just adds material into the spinning mandrel essentially. So that is kind of how every cylinders are made. Any carbon fiber, glass fiber cylinders, scuba tanks, CNG tanks, all these are made via this same winding process. So this is another additive manufacturing process, in fact. So 3D printing only came in around, say, 80s, actually 1980s. But composites, we have been using additive manufacturing process ever since.
Very interesting. So for you, it was just a process of going from manual to automated.
Correct.
And to use the advantages of robotic automation.
So additive manufacturing is just a class of manufacturing process itself, like how we say reductive manufacturing is additive manufacturing, right? Just a class of manufacturing. Just so happens that in case of composites, we always have been using additive.
Sorry, I want to ask a question. Is it reductive manufacturing or subtractive manufacturing? What is the right term?
There is no right word. You can use whichever one you're comfortable with.
Sure.
So as I said, right, the whole concept of additive manufacturing, metal guys and plastic guys would not disagree with me. So it is just a little bit of not very standard things that are there just yet.
Understood. So subtractive manufacturing or reductive manufacturing has all these processes, which is an umbrella term for lots of these processes.
Yes, correct.
You are saying that additive manufacturing also a lot of processes are coming together.
Yeah.
Or
so 3D printing is just one of the additive manufacturing.
Yeah, nice. Yeah. That's really cool.
The whole word 3D printing is very catchy, right? So when Stratasys held the patent on FDM technology, the plastic 3D printing technology, when that patent essentially died around 2007, I believe, that is when the whole open source 3D printing became very famous. Like everybody started building 3D printers on their own.
Yeah.
So that is where 3D printing blew up in a very big way.
Yeah, and I think that's when the IIT Madras Student 3D Printing Club started around.
A little later, but yeah, they took a few more years after that. But yeah, We did have 3D printers back then also.
I didn't have. Sorry. I never got to play around with the 3D printer. I want to ask you, but your company started in 2016, and it just like, I think I have met you a few times here and there, maybe in some events or something. And your journey has been one of like extreme doggedness, right? Like we are in this universe where people think of startup as I'll try it for 3 months. I'll try this idea. I'll see if it works. I'll try that idea if it works. Maybe I'll give it a year, and then maybe I'll go to a job or something if it doesn't work. But this is the opposite of that. You've been at it for 9-10 years. One, why does it take so long in your industry? And second, what gives you the confidence and the energy and the conviction to stay?
So yeah, I do definitely hit a point on this question. So one thing for sure is I always believe like if somebody comes to me and asks like what is the most important quality for an entrepreneur, I would say it's perseverance. At least from my perspective and my experience, it is that you keep getting challenges but you need to persevere it through. That I feel is always the persevere and be flexible about it, not just be stubborn. You cannot keep doing the same thing and expect some things will change. I think just the flexibility and persevering through the troubles that you face, that's what I feel is the most important thing as a entrepreneur as we need. But coming back, why it took a long time for me? Number one, the work that we are doing is not something that has been done in India earlier. People have attempted it and dropped it. We got to know that there was a very huge, well-funded process from NAL had initiated to build a similar technology that we were doing. And they had commissioned one of the big machine makers at that time. It was around a 15-year project that they did, and then they abandoned it, sort of. So this was a very heavily government-funded project, in fact. And similarly, there was a similar project running with DRDO also at that time to develop, because this is a technology that we needed in India as such, right? So in spite of several attempts, this is not something people have been able to crack. And we felt that we could crack it. We knew that we had the ability in terms of technology, capability, engineering-wise, we knew that we would be able to crack it. But the capital and convincing the investors that with this amount of capital, we can do it when somebody else with an even bigger capital, they're not able to do it. So it does take some amount of effort to convince the investors also. So the way we went about is in the first 2 years has been like, we needed to build a machine, right? Firstly, the machine needs material. The material, the way I get material off the shelf, I cannot directly load it into this machine. It won't work. So I needed to change the material property, form it into another form, which is not available. So that is the first step in our technology crack. So I needed to get the material, invent a material processing technology first, and then invent the machine. Because if I don't even have the material, I cannot do trials on the machine. So the first material processing alone took us about 2.5 years. Now I knew that this material processing will work, but without the machine in place, I cannot sell the material to anybody. But at the same time, if I had built the machine, like I would not have the materials to actually test my machine with. So it was almost like
So it's like two startups together.
Two startups, yeah. We had to develop the material first, which took a bit of time. And with that, we were able to start the prototyping of the machine very quickly. But we didn't have a full-fledged machine, but we were able to build just the MVP part of the critical technology part of the machine. And we had the material developed already. And we were able to demonstrate to investors that, see, this is a very quick MVP of the technology. The material part we have cracked, and the critical part of the mission also we have cracked. With that, we were able to go to investors and showcase and able to get the funding.
Two questions here.
Yeah.
One is, say the machine that you gave to IIT with the material, maybe that was last year. I can't remember. Was it last year?
About a year back, yeah.
How long did it take to design, develop that machine and that process?
So this, when I said like we cracked the material and the MVP of the technology, that took us about 4 years.
Okay.
All right. Just to come up to the MVP stage of the technology. So we did have to figure out a lot of things there. If we had better capital, it was just 2 people working in one of the working in my home, sort of. it took us quite a while, essentially, and we had 2 interns to support us. So there's just four of us working essentially. That did take quite a while. Once we had the mission, once we had the MVP, we were able to actually get about $500,000 we were able to raise at the time. That was the first round of funding. This was in 2019.
That is the second question I wanted to ask.
Yeah.
You were able to convince investors that I took 4 years to design this machine. It will take another 4-5 years to, people say that in India, investors are only investing in samosas and ice cream and all of that. But they have invested in your company, right?
So I was definitely exception back then. So today, there's so many investors willing to take a bigger bet, like invest in deep tech, manufacturing technologies, and so on. Back then, I was definitely one of the exceptions. Like in 2018, 19, and so on, there were not many people. One of the reasons I was able to do this, get this investment, is because this was an angel firm that invested in us, where many of them were engineers themselves. So I was able to go out and convince them, like, this is a technology, this is a capability of this technology.
When you're saying engineers, you mean like hardware engineers, not software engineers?
They were mostly industrialists in that case. So they were mostly like CTOs, CEOs of automotive companies, robotics, chemical.
That makes a lot of sense because in software engineering, 4 years to an MVP is nobody will.
Nobody will invest. Nobody will even like, what have you been doing? And these days, it's just a couple of days with AI coming into picture.
Yeah, correct.
But in hardware, nothing can be done about it. You have to build the mission. If it doesn't work out, like you have to rebuild the mission, and then the cost and the time that goes into it is multiplied that many times. So the number of iterations that you typically have in case of an hardware, any development, that's why kind of many VCs used to kind of shy away from it. But now they are seeing the value. Like if you can persevere through that initial phase, the value offering after that is insane. Like even another competitor comes into picture, we can actually protect some hardware invention via patents and so on, which is not possible in IT and stuff. So let's say you have Ola, Uber, Flipkart, all these guys, they all have operational strength, but what is the IP that they can protect?
Yeah, their moat is not a patent.
Yeah.
Their moat is just how fast they're moving.
Yeah.
Somebody else moves faster than them, they're toast.
What VCs are realizing right now is, let's say even if you just to crack the technology and even if you are not able to sell the technology out in the market, technology patent has a value and they will be able to sell that to another industry and still make their exit out. So that is something that more VCs are actually, more and more awareness is coming in around deep tech. The value of IP is being seen much more easily right now than what it was the case earlier.
Sure. Understood. So 4 years it took you to get your MVP, and of course 2020 the pandemic came in.
Exactly. So that's about 1.5 years we had to go on complete survival mode. So we did just some services here and there, just some consultancies, and we just did anything that we could to kind of survive. And then once the pandemic died down, we did a quick another bridge round from our existing investors, and some new angels also got in at that time. And with that, we were able to actually start entering into the market.
Nice.
Yeah.
So technically you've been in the market for maybe 3-4 years.
Actually 2.5 years.
2.5.
Yes, that's it. So that is when we were able to actually build the market and demonstrate to our investors, and also demonstrate to new investors that people are willing to buy. The technology is working in the market. So yeah.
Curious to know what is your personal history and how did you get here, and also like how did you learn to be so patient?
I don't know. I think my parents will definitely not call me patient. But yeah, with regard to this, I think we have been fairly patient, and we knew this is kind of how it is going to be. How I got into this particular area, I would say IIT had a very big role.
You were a student here from 2007 to 11.
2007 to 11, yeah. So that is when C5 was actually getting commissioned. So 2007, so you and Ravikant were big part in getting this going. In first year summer holidays, this place CFA got set up, and me and 7 other batchmates, we wanted to build something called vacuum blimp. So blimps, as you know, the air blimps that float in the air with the hydrogen or helium fill. So what we were essentially thinking is, if it is vacuum, it will be even more efficient. So we went about making a vacuum blimp, and we realized that if it needs to be even more lighter, it needs to be made with glass fiber and carbon fiber based on the little research that we did at that time. And then when we started building it, we realized that there is nobody in IIT Madras or others who has experience to build this thing. So there was one professor who had some technicians and himself, and we got trained by him a little bit. And then we started doing trials and completely we figured out on the go like how to fabricate.
Can I tell you some very maybe you already know this.
Yes.
When CFI was set up, we broke down a unit of the workshop. So this is the central workshop building, right? So every other
FRB.
bay is the so the FRP where we are sitting right now used to be the FRP bay.
Yes, exactly.
Which is fiber reinforced plastic bay. And you are telling me that the first team that moved into the new workshop building,
It just so happened, correct.
it so happened that it was a composites
Bay, we were building glass fiber components for the vacuum blade. So it is those people, the two professors and
those same
were there.
technicians.
So they helped us out to get some initial idea of how to handle the materials and so on. And then we had to quickly figure out everything. We made our own plaster of Paris molds and we made the whole place a big mess. But that kind of gave an idea of how manually intensive this whole process is. We tried to look it up. Is there more automated process out there? But no, unfortunately not. After that, I did a small internship in National Aeronautics Laboratory. So that is when the LCA Tejas program was actually coming up. So they were building the very first LCA Tejas tail at the time in NAL, and I was part of that team and got some professionally how they lay carbon fiber tails for fighter jets and so on. So that's kind of the next level of experience that I got, I would say, into this composites area. Then I worked with ISRO for a few years, and there also we did continue to see a lot of carbon fiber parts. We continue.
Your first job was with ISRO?
Yeah, that's right. So continue to see the same pattern emerge, and also realize that because these are all done by manual process, the rejections are also significantly higher. Like in metals or plastics, if an industry is making even 1% rejection, they will never get a follow-up order. But here, even 5% considered as amazing. So
in a machined process, in a metal machine process, in a lathe process, for example, the rejection will be 1 in 10,000 or 1 in a million or something.
Yeah, correct. But here it is almost like 1 in, say, 20 pieces, 10 pieces. So that is how bad the reliability of the manufacturing process is. And that cost kind of adds on to the user, of course, at the end of the day. So that's kind of where we decided, okay, this is a real problem, not just in India, but across the world. And trained technicians are very hard to get now. So people typically go through like 2 to 3 years of craftsmanship. They ITI diplomas and all, they don't know this. So people typically get onboarded. They go through 2 to 3 years of minimum craftsmanship training, and then they employ them on the production lines. So that's why we figured, like, you have a mission, you just program it and it should be able to replicate it and make it as many as possible. So that is really the vision why we started Fabheads.
So even as a student in 2008, 9, 10, you were thinking of this as a problem?
Yeah. I mean, like, I was very closely related to the problem. If I was not even aware of this problem, I may not even be considering building a solution later down the line.
So then you went to ISRO.
Along with me, not just me, like I wanted to definitely join a core job in India. I did get some.
Can you say that again? You definitely wanted to join
a core job in India.
Okay, thank you.
I did get some MS PhD offers in US, but I didn't really feel like I didn't feel like studying anymore. I wanted to do stuff, and I felt more resonated with doing core stuff, not really IT or stuff. And this was first incidentally. ISRO came for campus recruitment, luckily in my batch and my following batch also. Unfortunately, they don't do it anymore. And for that reason, I got fairly quickly interviewed and got into it.
Okay. This is great. So then you left ISRO and started this company, or was there a gap?
So I knew what I was going to do in this particular area, but immediately I didn't start. I had a small break where I was doing some prototypes at home and waking up neighbors drilling stuff through the middle of the night and stuff. But yeah, about 6 months gap I had, like basically figuring out
what to do.
Yeah.
And your co-founder is from IIT Delhi.
Yeah,
right?
correct.
So, and both of you were in ISRO. So it's not just IIT Madras, but also other IITs who are joining. So I just want to clarify that it does happen. There are people.
Yeah, I mean, like, the way this happened between me and Abhijit, my other co-founder, so he was working in composites back in ISRO directly. So he was making the biggest heat shields ever made by ISRO in carbon fiber totally. The payload adapters, satellites, anywhere composites was coming in, he and his team was actually doing it. And he was also very much into robotics, automation and stuff. So that was his inspiration towards, automating composites essentially coming into picture.
Very nice. Of course, it's taken you a long time, but you are right now owning and providing a service on a manufacturing setup, which only 7 companies in the world can do. I also think, as you were saying, this India has this national drone mission where we are trying to implement a lot of drones in agriculture and so on. And there is no way that we'll be able to make so many drones unless we own those technologies.
Correct.
Right?
Exactly. So as I said, right, not just drones, like you want to make fighter jets, you want to make submarines, anything that is made with carbon fiber today, we don't have enough trained technicians in India. So today, unless more such automation missions like what we are building is coming into picture, requirements of Indian defense or Indian aerospace will not be met.
Right.
Yep.
I want to ask you, so I got a sense of this. We spoke a lot about how Fabheads started, the doggedness and the perseverance with which you have pushed the company till now. You've raised funding this year. Can you talk us a little bit about your funding?
So we got about $10 million funding from Axel and a Trifecta Capital put in together. And with us, primarily the biggest expenses going towards setting up our newer factory right now, which we are setting up in Bangalore at the moment. Today, we are working out of a small R&D mini production facility in Chennai. And this will be our first large-scale production facility in about a 2-acre where we are setting up our factory.
Nice. Damn cool. Congratulations on that.
Thank you.
What is the we are talking of additive manufacturing in composites, advanced materials. So I think the field is called advanced manufacturing, right?
Yeah.
So what is the next 4, 5, 10 years of advanced manufacturing going to look like?
Yeah. Definitely the ultimate material today is composite material. So you look at more automotive, like for example, this probably amazing feature that I can talk about. You might have seen F1 cars crashing into each other at extremely high speeds and still the driver walks away safe. This is because the whole F1 car is made out of carbon fiber. Typically what happens is carbon fiber, one of the magical features of it is it absorbs all that impact crash and doesn't transfer that energy to the driver inside. That is how it actually ensures that the driver is still able to walk out safe. In Europe today, the impact requirements of even the simpler road vehicles is so high that the bonnet of the cars are being forced to be made out of carbon fiber in Europe, or glass fiber or carbon fiber and so on, from a safety angle. So you can imagine this kind of safety angle when it comes to India, you will see more forced adoption from a safety angle coming in. In Europe today, you might have seen LPG cylinders at home, which are predominantly metals in India, right? The steel.
We have seen that some of the companies are starting to move to a plastic.
Yeah, no, not plastic, glass fiber.
Glass fiber.
Yeah, glass fiber.
Indian supplies a
correct.
very light
Yes.
cylinder.
In Europe, metal cylinders are banned.
Okay.
Because in case of an external fire, glass fiber or carbon fiber cylinders will not explode, but metal cylinders will explode essentially. So lot of safety features are also coming into picture other than say fuel efficiency driven, lightweighting and all these things, corrosion resistance and so on. So a lot of environmental related drivers also now happening towards more and more composite adoption. So the biggest challenge in adopting more materials is automation, because there is not enough manufacturers out there, and the cost because of the way things are being produced.
Sorry, can I just interrupt you a bit?
Yeah.
In terms of additive manufacturing or 3D manufacturing of metals and plastics, the main advantage is that in reductive manufacturing, you can't get certain shapes. So you are able to get those intricate shapes, internal carvings with composite material, which was simply not possible earlier. So you can make more complex items. In composites, the advantages you are saying is that firstly, it goes from manual to automatic.
Yeah.
And secondly, you're saying that because
So
of this,
like you take a car, for example, right? Any of the body panels of a car will continue to be done with sheet metal only. Because a 3D printing will be too slow for a sheet metal works essentially. Where the benefit could be in the engine, where the engine could be very intricate, a lot of very complex shapes coming into picture. That could be ideally 3D printed. When the casting goes out, when the speed of 3D printing catches up to casting, that could actually be one of the ideal parts for 3D printing to actually take over in case of automotive and so on.
Yeah.
So in case of composites, as you rightly said, we don't have a competitor like sheet metal or injection molding or casting in case of composites. Today it's done by manual process. 3D printing, the challenge that pushback the 3D printing gets in case of metals and plastic is the speed is very low. You can get me very amazing shapes, more complex shapes, yes, but you are very slow, which because of it the cost goes up a little bit. But in case of composites, that's not the case. There is actually any other existing processor actually more time and cost intensive, which is because it is run by hand. So our automation is going to be actually faster than. So that kind of pushback which 3D printing gets in case of plastics and metal is not going to happen in case of composites.
Amazing. So for composites, additive manufacturing is an obvious choice.
Yes.
Or automated additive manufacturing.
Yeah, correct.
Is an obvious choice.
Absolutely, you got it.
And because of that, we will see adoption of composites into many more
Yes.
products.
Yeah.
Like cars, which we have never seen before, but it's more and more going to happen.
Yeah.
And the benefits are, one is lightweight, and the second is from a safety angle.
Correct. And what we are doing is going to make the production a lot more easier and also a lot more cheaper. So that is why the adoption of these materials can also be significantly accelerated by the technology that we are bringing in.
Wow. Okay. Fine. So when we are thinking of the next 5, 6, 10 years of additive manufacturing composites, you are saying that we will see these materials and these parts being adopted to a large number of products.
Exactly. Not just in automotive, like biomedical implants, if you can take, like for example, now the reason titanium implants like knee replacement joint, hip replacement joint, because 3D printing became such a very common thing. Like earlier, people used to make implants like standard says, like we pick up our t-shirts, like there'll be SCM, XL and so on. And then it'll be up to the doctor to actually, grind the bones or the implants and fit it to the correct socket. Now they do a scan and then they 3D print to the exact same shape with titanium and they just insert it very quickly. And carbon fiber 3D printing can do that even better because it's more organic material and it bonds much better with the bone. And it is well proven that carbon fiber is a better material. With 3D printing of carbon fiber, it can meet the benefits that titanium was earlier offering. So like this, slowly the adoption will enter into multiple industries. So that is what our technology that we are bringing in.
So all these companies which are making all these products will turn to you because you're going to be the guy who can manufacture and make those products
in an automated manner.
Yeah. Amazing. Congratulations and thank you so much for sharing so much with us. I would want to ask you a little bit about sorry, I just keep coming back to this because in my experience, you've of course met a lot of entrepreneurs and I've been an entrepreneur myself. The level of doggedness and perseverance that you have gone through is intense. So you told us why it took so long and your equation with investors and so on. But on a personal level, doesn't it get exhausting to wait and to push 4 years for an MBB and so on? How do you manage that? The kind of to build something that is unique, patentable in a hardware space, the amount of time, energy it requires, how do you manage that from a personal level?
Yeah. I mean, like, that's probably why I said perseverance is one of the key important things.
Don't you get up sometimes and say, this is done, I'm done, I'm just going to get a job?
So typically, like, even if the thought comes across, right, it will probably go away in about 10-15 seconds or so. Because I know that I can get it done still. I mean, like, I would be completely wrong if I say that the thought never come across, but it usually goes away quick as fast as it comes. At least for me, it does. So, because I believed in the product, what we are building is definitely out there. It's just about convincing the right set of investors to say that we are there, this is the technology, and this can do this magic thing in the world, and you need to believe in us. So, we did hit a lot of roadblocks like during pandemic and a long route and everything. But we had some very good supportive investors who had invested in the very first round that I talked about. Whenever we wanted some...
Should I just say, are you saying that your conviction in your thesis was very, very strong?
Yeah. And we also were flexible about about 2018-19, I went to showcase the same MVP to a couple of clients, and we incorporated a lot of that feedback also. So it is not like I just blindly built something and I expected it to work in the market. So it's not like the very first thought process on how to go about it is what we are implementing right now. Definitely not. So in fact, earlier we thought that it would be actually the easiest way to sell the machines instead of do it. Actually, we felt like it is more easier to manufacture and sell the products rather than convince them to change their whole factory to fit our machine into their flow.
Understood. So you're saying that you were clear that this will come in,
Yeah.
but you were flexible about
How to go about it.
how to go about
Yeah,
it.
there were a lot of, even on the business model, on operations level, lot of things we needed to change about. Like even initially, I thought that I will get 50 crores easily. This was way back when I just had a MVPN, right? But all we got was like 4 crores at that time. So my plans for 50 crores was something, and then I had to really step down and then go about, okay, now if this is all that I can get, like how can I demonstrate enough of the technology so I can convince the next stage of investors? So a lot of changes I had to do on how I went about it. But yeah, definitely I knew at the end of the day what the ultimate vision is, that remains the same.
Understood. Okay, thank you for spending some time with us and explaining this to me. I love this because first of all, I'm from manufacturing. Actually, I studied manufacturing. I shouldn't say I'm from a manufacturing background, but I did study it in college. So it's fascinating for me to learn something in that space, how it's moving, and thank you for sharing.
Absolutely.
Any last thoughts? Any advice you want to give our audience?
I would say, I mean, like IITM, the whole thing about building the vacuum limb was actually my stepping stone into the world of composites. Definitely, the whole tagline of this particular project, best place to build, I think I resonate to it very well. Nothing more than that.
Thank you. This was great. And there you have it. Thank you for listening. If you want to know more about this company, head to their website or their LinkedIn. You will find them online. Thank you so much for watching. Please remember to like, share, subscribe, and see you next time.